Hi guys, welcome you all to my channel Explore Edu to Teach.
So welcome back to my channel, and today we'll be learning about few numericals on the subject PN Junction diode. There are already videos uploaded on my YouTube channel in digital electronics playlist wherein we have spoken about introduction of PN Junction diode, drift and diffusion concept, the current densities, the barrier potential and depletion region, and we solved what is a capacitance and what are the different terms, like you have the depletion region width, then you have the electric field equations, then we solved one question that was asked in gate examination in the last class. So please watch out those lectures are very important. I have tried to make you understand each and every term very well. So in this class we will be solving few numericals. This is one numerical that we will be solving completely. Next one is this numerical, and the third one is the below numerical as given. So we will be solving three numericals. A bundle of formulas are going to be used in this. All these formulas will be uploaded on my Instagram page. The links of my Instagram page is given down in the description box. You can go and check it from there, and if you like the page you can definitely follow me. There are regular updates on my Instagram page in terms of my stories, in terms of the different pictures which are put for different formulas, different concepts, short videos which will help you at the time of your examination. So please do check out the links in the Instagram page. Also along with that, this notes will be present in the description box of my YouTube channel as well. You can go and download it from there. So in this numericals we'll be solving and we'll be using a number of formulas. All these formulas page number output, that is where is those formulas explained in this particular notes. You can see it from there, but it's very important to know the formulas very well. In EDC, especially in PN junction kind of numericals, you should know the formulas very well. There are a number of formulas, and in the last class I have explained all these formulas, like the depletion region width, the electric field equations, what are each and every term in that, very well. So if you understand those formulas very well, it will be easy for you to solve this question. Just biting or just mugging up the formulas is not going to help you. If you know the formula, if you know each and every term in it very well, then you can map those terms onto this question and solve the answer. So I hope I am very clear. So let's try to solve the first numerical. The first numerical says, assuming electronic charge Q is equal to 1.6 into 10 raised to minus 19 coulomb. The kT by Q is a thermal voltage is given as 25 millivolts. The electron mobility mu n is given as 1000 centimeter square per volt second. If the concentration gradient of electrons injected into p-type silicon is 10 raised to 21 per centimeter raised to 4, what is the magnitude of electron diffusing current density, which is asked in ampere per centimeter square. So it's very important for you to know first the formula for the diffusion current density of an electron. It is given as Q into dN by dx. This Q stands for the electric charge, dN is basically the diffusion constant, and dN by dx is the concentration gradient. So if you see over here, first of all you have plus Q. So Q is 1.6 into 10 raised to minus 19 coulomb. If this point is not visible, I am not sure if it's visible or not, but it is 1.6. Okay, so it's 1.6 into 10 raised to minus 19. The next term is dN. So what is the formula for dN? If you see, dN is equal to mu n into Vt. Okay, what is this mu n equal to? The mu n value is clearly given in the question as 1000 centimeter square per volt second, and Vt is the thermal voltage which is given as 25 millivolts, that is 25 to 10 raised to minus 3 volts. And then you have dN by dx. The dN by dx is straight away given as concentration gradient as 10 raised to 21 per centimeter raised to 4. So just substitute the value of Q, dN is equal to mu n into Vt, and then you have dN by dx, which is over here, and try to find out the final answer. I hope I'm very clear with this. Okay. Next you have a silicon diode. A silicon diode is doped with Na 9 into 10 raised to 16 per centimeter cube on P side and Nd as 1 into 10 raised to 16 per centimeter cube on N side. The total depletion region width is 3 micrometers. The permittivity of silicon is given as 1.404 10 raised to minus 12 farads per centimeter. The depletion width on P side and the maximum electric field in depletion region, that is WP and E, is given as. So again, see, it's very formula based. When we see the solution, you'll find that it's just a formula based kind of question. If you are doing the calculations correctly, if you are using the units very well, and you are doing the formula very correctly, trust me, you can score in these questions very well. Not only in a university exam, but also in GATE examination or competitive exams also. From EDC, basically the questions which come are basically formula based. So if you know the formulas, it's easy for you to solve the question. So what is the formula for WP, that is the depletion region width on P side? The WP is given as W, total depletion width, into Nd upon Na plus Nd. What is this W given as? The W is basically given as 3 micrometer. If you see over here, it is given as 3 micrometer. This micrometer you have to convert in centimeter. Why so? If you look at the question over here, everything is given in terms of centimeter. Na is given in terms of centimeter. Nd is given in terms of centimeter. The depletion region width can also be given in terms of centimeter, and the permittivity of silicon can also be given in centimeter only. So what I want to say is that you have your Na, that is your acceptor concentration, is given in terms of centimeter. Nd is given in terms of centimeter. The depletion region width is given in terms of centimeter, that is 3 into 10 raised to minus 4 centimeter. Okay, the micrometer meter was given, but we have converted that to centimeter. And then you have to find out the value of WP. The WP is given as W into Nd upon Na plus Nd. Just substitute the formula of W from here. Na and Nd is already given clearly in the question, and you can find out the final answer in terms of centimeter. Similarly, the electric field equation is from page 16. In the notes in page 16, you will get this formula. It is given as Q into Na into WP upon epsilon. So the Q value is already, 1.6 into 10 raised to minus 19. Na value is given very clearly in the question over here. WP is also found out from up, and epsilon is given as 1.04 into 10 raised to minus 12 farads per centimeter. Hence you have the final answer. Similarly, you have the next question, which says a n-type silicon sample is uniformly illuminated with light which generates 10 raised to 20 electron holes pair per second. So here the rate is given to you. 10 raised to 20 is the rate. The minority carrier lifetime in sample is 1 microsecond. So this is the time given. So in steady state, what is the whole concentration sample? If it is 10 raised to x, what is the value of x? So if you know, the concentration value is basically equal to generation rate into lifetime. So straight away use the formula. Generation rate is given as 10 raised to 20. The lifetime, the time period is given 1 microsecond. So the whole concentration is generation rate into microsecond as 10 raised to 14. If I compare it to 10 raised to x, x value is 14. So these are just the simple numericals which are there. If you would have seen, these numericals are simply formula based, and so if you know the formulae, if you are seeing the units very well, whether what is given, meter, centimeter, what is given, and you can apply them onto the numericals very correctly, trust me guys, you can get the concept very well and you can solve the questions. So this notes will be in the description box of my YouTube channel. The Google Drive link will be given to you. The formulas, specifically important formulas, will be uploaded on my Instagram page. The links are given down in the description box. You can check my Instagram page also, and if you like it, do not forget to like, share, subscribe to my YouTube channel and follow me on Instagram as well. Thank you so much guys.